So what we're going to do here is we're going to reverse the process that we've been working on. It still deals with personal finance, but you can't always save money for something you want to buy. Think of cars, think of college, or think of homes. These are things where people do take loans and get hold of the item early and then pay it back. About loans, you actually own the house if you have a mortgage on it, but the bank doesn't own your house, so if you want to hang a picture, you don't have to call them and ask if you can drive a nail in the wall. You own it, but they have the right to take over the house if you stop paying them. But as long as you're paying them, it's your house. So that's what a mortgage is. The same is true about a rental car, a car. If you finance a car, there are certain rules. You have to have insurance and all that they want you to do until you're done paying for the car. But it's not like they own the car and they're like, oh, I need the car Saturday night, I'm gonna go over to Fred's house and take his car because he owes our bank. So you own it, but you have what's called a secured loan. The secured loan means that the item that you're buying is functioning to say, this is why we can loan them money, because we'll get that money back from them. So a secured loan could be for a car where they take the car and sell it and get their money, or take your house away from you, put you out, sell the house, get their money. If they get more money than they need to, they'll give you the extra. If you don't get enough, that's a different kind of problem. But that doesn't happen with college loans. They can't really sell your education. So college loans are a little different, but they all run this way. What we're going to do is there is an amount of money that you borrow, and we're going to have that be our P right here. Right? P is going to be the principal of the amount of the loan where it starts. The first thing when we start up the loan is how much money do you have to pay back? And it's not just the amount that you borrowed. It could be more, it could be less. There are two things that affect how much money you owe besides the original amount. So you have the price, okay? Plus you might have these things called closing costs. And then minus something that we call a down payment, which is a good name for it because it's a payment. And in the old days when it was done with cash, you would actually put the payment down on the table so that the bank would take that money from you, and that would decrease the amount that you have to pay back because you're giving them some money now. And the down payment is to make sure that you pay some of what the house is worth. And the housing crisis that happened about 10 to 12 years ago was driven by a lot of the time there were not big enough down payments. People didn't really own through their own money some of the property that they were involved in. They had 100% of the property, or even a price more than the price of what the house was worth, and that led to some problems. So the down payment is what some people would call skin in the game. You put your own money in so that you're committed to this purchase and you're not just borrowing all of it. The kinds of loans we can look at here are when you buy a house, you're going to deal with the price, you're going to have some closing costs, and generally you'll have a down payment of somewhere between 3 and 20%. It could be more than that. If you can get to 20%, then you don't have to pay PMI, and we'll talk about that in a future lecture about how to keep your housing costs down. For with a car, you pay the price. You might not call them closing costs, but there are other things besides the sticker price of the car that you have to pay, right? You got to pay tax, and then there's the dealer fee and all that other stuff that they do, and that comes up with how much money you're going to owe them. And then there's also a down payment, which might be money that you bring to them to show your interest in the car and to invest some of your own money into the car, or you might trade in your old car and get that to function as your down payment. But when this is all done, is going to be our amount financed. And the amount financed, where the loan starts, we'll call the principal, so we can use it in this formula. Now PMT is not P times M times T, but P is already taken by our principal. So PMT stands for our payment. So what we're doing here is we have our payment that is going to be driven by P, which is going to be how much money it is that needs to be paid back at the beginning of the loan. So that's going to be our principal, P. R is going to be still our periodic interest rate. You take your R, divide by 100, so it's the percent is dealt with, and then divide by N. Most of these are paid off by the month, so you use a 12 to multiply your number of years by 12 and to divide what you did with R by 12 to get down to a monthly rate. If it's weekly, because some places are buy here, pay here, and you pay weekly, then it'd be divide by 52, get a lower rate, multiply by 52 to make more payments. But those are staying the same way they've been when we're saving money. And that was my purpose in designing it this way, is to have the consistency of the rate and the number of periods. And P is, in this case, the beginning amount of the loan. So down payment right here, just to make sure that you have, that I didn't miss any part of it. This is the extra money that you bring to pay and put down at the closing. It makes you borrow less. So you lowered the down payment. The down payment lowered by that amount how much you're borrowing. It's often a percentage of the sale price. Closing costs are extra costs that you pay besides the price, right? So they make you borrow more or increase your payment. So you begin with the price, increase it if there are any closing costs, and decrease it if you have a down payment. Now with a student loan, the price is the amount that you consider yourself borrowing. There may be some closing costs to the loan, but what they'll do, if you go and borrow $5,000 and there's $300 worth of fees, what'll happen is they'll say you borrowed $5,000 and they'll take the $300 out, and when they send the money to your school to pay that bill, they'll send them $4,700. So you are still paying your whole $5,000 as what you're financing, but you don't get a down payment on a college education. You just borrow the amount that you need to borrow, because there's no item that you're actually putting money into, so there is no down payment when you're dealing with that. So just to make sure that we see how these things fit, and I didn't miss any parts of them, there are closing costs on car loans and student loans, but we don't call them that, right? There'll be fees mostly, things like that that are in there. And down payments are part of car loans, but not student loans, and definitely down payment is a big part of buying a house. So with the student loan, just borrow as much as you need, right up to that dollar amount. Cars and homes often require down payments so that you can already have something invested. These no money down lending things led to the housing crisis. When they said, oh, you don't have to put any money down, the houses are going up in value all the time, don't worry about it, we'll loan you all the money and then the house will go up in value and you'll sell it and everybody will be rich. It didn't work out that way. There came a time when that stopped happening. So here's the deal with installment loans. Installments are little parts along the pathway of your repayment. So installment loans is they're going to be paid back over a set time period. So you know how long you have, how many periods are going to make up a year with the lowercase n, and you're going to make the same payment each time, except for the last payment may be off by a very small amount. So the same payment is due each period. So what we have to do is look at the fact that over time, you're going to owe less on your loan because of what's happening. You start, say you borrow $10,000, and then the next month you pay $300. Some of that was interest. So instead of them saying, you know what, let's knock their loan amount down to $9,700, they'll take the interest off of how much credit they're going to give you, and whatever extra you paid on top of the interest is going to start to slice amounts off the principal for the next cycle of payment. So that what we have to do is get it so that when you finish your time period, it comes down to zero. And somehow we have to come up with the number that's going to get that job done. And this formula does it. This is another formula I'm not going to derive for you because I could go through the process of doing it and lose some of you, and maybe a few of you would follow, but it doesn't really matter that you can follow my derivation of the formula. We're going to use the formula to get the right payment, and then we're going to jump on the computer over the shoulder, look at Excel, and watch how it hits right about at zero. It might be off by a few pennies so that your last payment could maybe be a little bit less. Okay, so we're going to say each payment is going to be the principal times the periodic interest rate, and then in the denominator we're going to begin with 1 minus, this is 1 plus r, that's our factor for each period, what goes on for interest, and that is to the negative power of n. So we've got to be able to get that into our calculator and have it get us the value of what the payment is. A lot of times this one up here we can turn into not an integer but a terminating decimal, and down here we've got some mess coming up, so we'll start with what's on top and then we'll divide by whatever we've created in the bottom, which might be a decimal that keeps running on. So let's look at it this way. If you buy a car and finance $24,000, now what this has done is it's already said, all right, there's gonna be $24,000. Got the price, you add the closing costs, then you set up the down payment to be the right amount to bring you right down to $24,000. Over 5 years, which for me is my recommendation of what I think is the most years you should finance a car that's brand new, and I believe that for a used car, 3 years. Just because that's gonna have it in such a way that by the time you're done paying for it, the car still has some value, so you're never way out of line. When you get a 7-year car loan, very quickly the car can be worth less than you owe on it. Those are just numbers that I've used in general. They do have larger numbers for people to do that now. And so if you buy a car and finance $24,000 over 5 years at 6% APR, that's your APR, find the payment. So we need to get P, R, and N. Same as before. P is the principal. In this case, I didn't have to do the down payment and all that. I know that it's coming right at me. I'm dealing with $24,000 is the initial principal on the loan. And that's the only principal you put in when you're using this formula. R be the interest rate. So this is 6%. 6 divide by 100 for percent, and then divide by 12. Okay. So what we come out of here with is we get 0.06 and we divide it by 12 and get 0.005. So you'll see that nicely terminating. And we need N. How many payments is this? This is 5 years, but it's not 5 payments. You're going to pay 12 times a year. 5 times 12, total payments 60. And so we want to find out what the car payment's going to be. And what I want to do is show you this car payment work and then show you how it starts to do its process, like 3 months of payments, what it does. We'll do them by hand calculation. Then we'll jump over on Excel, we'll create the same hand calculation, we'll run it through the 60 months, and we should wind up right around owing 0 at the end. So we have the payment equals P is 24,000 with the $sign. R is 0.05, so we'll go 0.005, and that'll get me a nice number in my numerator. It turns out not to be too extended into fractions, decimals, and so forth. And now we've got to do this. Down here we begin with 1 minus, and then we have 1 plus the 0.005, so that's 1.005. Again, if you have a non-terminating decimal, you'll put in the parentheses 1 plus your value for APR, divide by 100, and divide by the lowercase n, and let it run itself out. And the n here I have is to the power of negative 60. N is 60. That is going in as a negative power. That's a common miss. People often miss that being negative. Okay, so I'm going to grab my dollar store calculator, and I'm going to take my 24,000 times 0.005. So 24,123 times 0.005. And I get $120. It's still got the $sign on it. Now I'm going to get to work on what's happening in the denominator. The whole denominator is 1 minus 1.005. And now that 1.005 that I'm now looking at needs to be raised to the power of negative 60. So you make sure that it raises to the power, and you put in a negative 60 the way that your calculator needs that to happen. So on this one I need to put in the 60 and then make it negative. And when I do that, I get this. 0.258627803. And now what I need to do is go take my 120 and divide by that. I've been doing it quicker than I've been telling you because I wanted you to be able to clear it and write all your numbers and all that, but I'll share now what I've been doing to get these values done. What I have on this calculator right now is the 0.258627803 sitting on this calculator. The only thing is it belongs in my denominator. So what I'm going to do is I'm going to, with that sitting there, instead of retyping it, I'm going to hit the second function and find where it says 1 over x, and I'm going to jam that into the denominator. And now I'm going to multiply what I just created by 120. And if that makes sense to you, you can use that as the way to take what needs to be in the denominator and put it there. This is 120 times that thing that I just created, and it gets me this value, 463,987. So 463.99 is what that's going to go to. So it's pretty much $464. It's a penny less than $464. Now, if this thing has anything beyond the 98 cents, if you give it less than that part with the extra decimal, it's going to come up a little bit short. And that means that your final payment might need to be a little bit bigger. And I always like to have the final payment be a little bit smaller. So even if this showed up as 0.982 or 3 or something like that, I would still, in reality, be charging the 463.99. But in this case, you round it to the nearest and it'll be fine. So that's how we got that value. We need to get how much are we borrowing, and we'll look at some in the homework where we have to do a down payment or maybe some closing costs that change how much we're going to pay. And we're going to adjust this number till we have a number of dollars that's initially being borrowed. Then we're going to go with R, divide by 100 for percent, and divide by how frequently per year you pay it. And then we're going to take the number of years times how many times per year to get our numbers and pop them into that formula. This is straight multiplying and get the 120. People don't tend to have trouble with that. But on this one, if the 0.005 did not want to work out, I would type this in the order that you're about to hear into my calculator. 1 minus open parentheses, 1 plus 6 divided by 100 for percent, divide by 12 for monthly. Close the parentheses. That will create where I have the 1.005, a decimal that didn't want to terminate for you, and it'll let the calculator store that to the best of its ability in its memory. And then I would hit the Y to the X key or the up caret to let you do the power. And then you have to know your calculator. How do you put -60 in your calculator? Some of the lower cost calculators need you to put the 60 in first and then hit the +/- key to reverse that to a -60. Others need you to hit the parentheses around a dash, which means negative, not minus, and follow it up with a 60. It's your job to know how your calculator is going to take that in. Now, all this stuff is going to happen in the right order. It's going to figure out what that is. It's going to take it to the -60th power because it's going to do the parentheses first. It's going to do the exponents next. And then it'll say, oh yeah, you were subtracting me from 1, and it'll get you to that. And if you have to write this and write that and type them all again, that's fine. If you want to use it to the fullest capability of your calculator, then the 120 is something I'm not worried about typing in, but this is a decimal that didn't terminate. So I'm going to make sure that what was sitting here gets in my denominator and multiply it by 120. Or even I could do 120 divided by this, having written it out, and take it as far as you can, then round it to the nearest penny. So that's how we're going to do these. Now there's something else going on. Besides finding out what your payment is, and you'll get several opportunities to work on that formula in the homework, we need to see how the money gets allocated across the 5 years. Now this 5 years is 60 payments, which means we're going to have 60 months of payments, and they give you, a payment book, or maybe they'll give you a spreadsheet that shows what your payments are going to do when you sign for the note. You can say, can I have a payment schedule? And they'll give it to you. And if you pay on time every month, it'll get there right on time for the last payment. If you pay extra, any extra money you pay in addition to your payment comes right off the principal, and that means that starting the next month, you're not going to pay as much interest as you were originally scheduled to pay because you took some extra money off the principal, which is why some people pay extra every month. If they owe on this thing, if they owe $464, if we call it that, they might pay $500, and then they could see that by doing that, they finish a couple months early or something like that, and that's money that they save on interest. So we're going to leave that up there for how you did your computation. And what we want to do is we want to go with the month number, and we want to go the new balance. Okay, and then we want to go here, we want to do interest paid for that period. And then this is going to be, this is going to be what we'll call the start balance. It won't be always new. Start balance, and then what's going to happen is we're going to have the end balance. And we're just going to do 3 months of this. This is $24,000, so we're going to set these up. 1, 2, and 3. The first month, you begin by owing $24,000. Now the interest that you pay is the interest that we pay for a single period. So this one, right here, I'll call this A, and I'll call this B. A is going to take my $24,000, 1, 2, 3, times 6, divide by 100, and divide by 12. $120. Now that was found because I took the $24,000 that the month started with, times 6, divide by 100, and divide by 12. And that got me the $120, and that drops in here. Now there's something else going on before I change up my balance. I paid $463.99, and the payment is the same every month. But each month, that $463.99 does a little bit more to help you get out of owing them money by paying off a little bit more principal as the months go on. $120 was the interest that you owed on that. So we're going to go like this now as we start to work on B. We always go back to the $463.99, and we're going to subtract, in this case, the $120. And we'll see $343.99. That doesn't go onto our payment right now. What this one does is it's going to say, where did we start? We started at $24,000, and we're going to subtract the principal that we don't see here, the extra money we paid besides the $120. If you add $120 to that, you get your $463.99. But we're going to go ahead and subtract $343.99 off that. And we get 24343. Let's see. What do? We subtract 9. How did I do that? I think I did that wrong. Let's clear it out again. 24, 1, 2, 3. The 24,000 back in, minus 343.99 equals 23,656.01. Okay, how does the next month start? You don't owe $24,000 anymore. You owe $23,656.01. So now we're bringing this number down here to start off the next month. So that I don't even count as step A. You do have to know the way you end the month is exactly the way you start the next month. So here we are, and we have that $23,656.01. Then we're going to multiply it by 0.005. That's the same as if you did that number times 6 divided by 100% divided by 12 because it's monthly. So we got 23,656.01 times 0.005. We get 118.28. And so we'll write that up here as 118.28, and then B, we'll find that we're going to start with the total payment of $463.99, and we're going to subtract the 118.28. So we got our 463.99, and we'll subtract our 118.28. Got to do it again because I hit one key wrong, but I did recognize it. 463.99 minus 118.28. 345.71 does not enter into the chart the way I've written it here. 345.71. We want the 345.71 to be the B, first value occurring in B, because that's how much money I paid in addition to this when I send him my check. And that's what's going to credit me toward lowering my balance that I owe. So I'm now going to take the 236.56, 236.56.01 and subtract that amount. And I'm going to come out of here with 23,310.30. That's how the next month is going to start. And now I have an A and a B to get here. Now that B, we use that to see that we started the month off again. We were 23,656.01, and we subtracted this amount of 345.71 off, and that caused my end of the month to be 23,000 still, but now 310.30, and that goes here. This is a good time for you to stop your playing of the video and try and finish out the month. If not, you can watch it and then you can replay it. You also see this on the homework. But what I have here is 23,310.30 to start the month. And I'm going to go do the next two calculations straight through, and you can play them through at your own pace. 23,310.3, I'm going to go times 0.005, and watch this one come out as 116.55, which is not paying as much interest as I did when I owed that bigger amount when I now owe this less amount. So that goes in there as interest for this month. Now I have to go ahead and find out, what do I get when I'm working on B? I'm going to take my total payment of $463.99, and I'm going to subtract 116.55. Now I'm at 347.44. Let's find out. Making sure on the calculator, I got the old 463. It's always the same payment, so that part is always reloading at 463.99. Subtract 116.55. 347.44. Okay, that doesn't go into the chart, but we take 347.44 away from this value. And we're going to see where the month ends, because we're knocking 347.44 off of the old 23,310.30. 23,310.30 equals 22,962 and 86 cents. Now, if you can look at what's happened here, we've made three payments of very close to $464. We even call it $470. If we look, that's $1,200. It's like over $1,400 that we paid. But our balance that we owe didn't drop off by $1,400. It dropped by a little more than $1,000, which looks like maybe I paid $100 or so each month extra. That was the interest that makes up these values here. and that's causing that to drop. And that's the first 3 months of what's called the amortization. So when you ask them to show you the table of what your loan payments are going to do over the time that you're in the loan, you're asking for the amortization schedule, and that's what this is. We're going to now create the entire schedule in Excel in far less time.